Alright, so this video we're going to go through a lot of things, but none of them will be very much in depth, but basically we'll be taking an adaptive component, then we'll be building that in Revit, and then we'll basically do an export of our lever house model here into Rhino, and then do some things in Rhino and Grasshopper regarding the facade, and then use that information and pipe it back into Revit in order to place the adaptive component. So let's just get started. So for the adaptive component, new family, generic model adaptive. And this is really, the point of this exercise is to kind of give a quick intro to adaptive components and interoperability, as well as a little bit of Grasshopper. And we're going to be utilizing this Hummingbird add-in for the interoperability portion. Alright, so we'll get started. So I'm just going to build a fairly simple panel that gets placed with 4 corner points. So those will be my 4 corners of the panel. Select those points. I'm going to make them adaptive, and you'll see it kind of numbers them 1, 2, 3, 4. So I'll have to just be aware of you don't want to, based on how you're setting up your workflow, you want to be careful about doing this in an order that makes sense. All right, so now I'm going to place a reference line. I'm going to turn 3D snapping on. I'll just draw these points. Okay, so now if I move around these points, that reference line adjusts as well. And then I'm also going to draw a reference line, so I want to get like a rough midpoint of the panel. So I'm going to snap to the midpoints here. Just test this. I'm not very good with adaptive components, so I always like to test as I'm going to make sure it's doing what I expect. And then this, we're going to basically put a point at the midpoint here. And then we're going to use that as our center. So again, I'm just going to make sure that the midpoint is moving. Okay, that looks good. So I'm going to draw a vertical line up from that point. So I'm going to select the point. I'm going to draw a reference line. I'm actually going to turn off 3D snapping. I'm going to draw on a plane. So now, the mouse just jumped. All right. So now we have this vertical line here, and we're going to place a point on this. But first, what I'm going to do is I'm going to create this is basically going to be sort of like the depth of the panel that we're creating. So I'm going to click on this dimension icon here to lock that. And then I'll assign a parameter here. I'll call it panel depth or something. I'm going to make that an instance parameter. Say OK. Alright, so now I'm going to host a point on that line. So I'm just going to click here, and then I'm going to come back, and I'm going to select that and make sure that it's hosted to the line. Alright, so now if I click on this point, I should see here that if I go to 0.5, that should move down to halfway on the line. Okay, so that looks right. And then I'm going to draw just a rectangle on the plane of that point. Actually, I want to contain that point within there. So let's see. All right. So if I move this point, let's make sure that the rectangle moves. And actually, I'm going to redo this so that it's a reference. Okay, so let me try that again. Okay. All right, so now I'm going to throw some dimensions on here. So I'm going to create a line dimension, and I'm going to click that line, the center line, and then the end, and set them to equal. Likewise in the other direction. And then I'm also going to do just the opening overall, and I'll assign a parameter here. Call it opening width, and I'll make that an instance parameter. Okay, so now I can test these out. So actually what I'll first do is I'm going to move this point so that it's at the end of the line. Now I'm just going to test to make sure that these things are working here. So if I make that 5 feet, it adjusts. I can drop this down maybe to 8 feet or so. Okay, so now the last part is I'm going to basically tab select into these, and I'm going to create a form. So this is essentially kind of like a loft operation between these two lines, these two reference lines. Okay, so that's basically going to be, I'm just going to test to make sure this is working. All right, so it's going to keep it pretty simple for the purpose of time for this demo. So I'm going to save this out. Start a new one here. We'll just call it adaptive panel. Okay. And then I can jump back into my project, and well, let me first load it into the project. And I'll just kind of place it out in space to make sure that it works. All right, so it's roughly working. So I'm going to basically be placing it on this facade. So now the next step is I'm going to show kind of just a simple way to export from Revit into Rhino. I'm going to actually I'm going to duplicate this 3D view. And I'm going to just simplify what shows up here. So for the purposes of this demonstration, I might probably just going to bring in a few things. I'll bring in floors, I'll bring in walls, maybe I'll bring in curtain panels. So it's good to always create, like if you're doing exports into Rhino or Navisworks or some other software, it's good to create your own 3D view. So like I can rename this Rhino export or something. so that I know that this view is specifically set up to have only the things that I want to export. Now, the next step when you're exporting is if you scroll down here, when you go to export, you have options. And I'm going to just be doing a DWG, so I'm going to see my DWG options here. Now you can mess around with some of these settings if you want to be particular about the layer naming and things like that. The main things to really be concerned about here is know what units you're exporting in, so I'm going to be in feet. And then I want to make sure that this is set to ACIS solids. I think by default this is often set to polymesh, so you just need to make sure that you change that. And now I can export this, so I'm just going to do an export. Maybe I'll just do an older DWG. Shouldn't really matter, but it's just a habit. Alright, so now I'm going to bring this into Rhino. Actually, first, let me just check. You always want to make sure that you're in the same units. So I'm in feet, so that's good. That's one thing to always be careful of when you're going between Revit and Rhino, is know what units you're in. Okay, so now we'll import this, and we should know that we're going to be at the right scale. Alright, so we have our model, and usually the first thing I'll do is I'll just double check that the distance looks to be at the right scale. So that's 162 feet, that looks about right. I'm just going to go to a shaded view here. Now, I have a bunch of, basically for this exercise, all I'm really going to be doing is I'm going to take this facade, this face of the building here, and apply a facade treatment to it with the adaptive panel, with the adaptive component that we just made. So I'm just going to create a new layer. I'm just going to call it adaptive layer, whatever. And I'm just going to draw a dumb surface. Just keep it simple for now. So I'm just drawing a big rectangle, and I'll be able to use that as my surface, and then I can hide all this other stuff. I can probably delete these other layers here if I wanted to. Okay, so I basically have kind of, I'm going to leave the floors just so we have a sense of scale. And so I'm going to use this as kind of like the base for the Grasshopper script that we're going to do. Alright, so I pre-baked a couple things in here with the Hummingbird component just for the sake of speed, but we'll essentially be working from scratch. Alright, so the first thing that we're going to do is bring this surface in. Set one surface. Okay, so now that surface is set. And we have to think of, there's a lot of ways we can start to kind of break this down. Essentially what we want is a gridded surface with sets of 4 points for each of the corners of the adaptive component. So there's an infinite amount of ways we can do this. I'm actually going to turn it into a mesh and then get the faces of the mesh in this demo. So, let's see. There's a mesh surface component that we can use here. So if I have surface, and then I can create like a U and V. So I'll do some numbers for these sliders. I know that I did 17 by default because I know that one of these has to be 17 if we want to match that floors, because there's 17 floors here. So we can look at the mesh edges to see. This is just kind of to help visualize the U and V breakdown real quick. Actually, what I'm going to do this. I'm just gonna, so we can see it a little bit better. All right, so let's see. Okay, so I want my V to be 17, so that aligns with the floors, slabs. And then I'm going to make this like, I'm just going to keep it as a lower number, do 11, just so that we don't have too many panels, just for the speed of this exercise. All right, so now let's see. Do face boundaries. I'm going to pull up a panel to see what I'm getting here. All right, so I have 186 panels basically, so these are all my faces. And this is giving me a polyline curve, and then from there I can do, I can check the control points. And that'll give me the points. Now you'll notice here, I'm going to delete this right now. You notice one thing is that these, each of these rectangles actually has 5 points. And that's because you're kind of going back, you're starting and ending with the same point. So the 0 point and the 4 point are going to be the same. So in this case, we want to get rid of one of those. So I'm just going to cull, and we're going to talk more about lists and data management in the next upcoming classes. So don't worry too much about if you don't understand this quite yet, but it's good to start to look at these things and start to understand that in this case we have basically a list of lists, which is a list for each of our panels of points. And we want 4 points, not 5 points. So I can do essentially, I want to cull the 5th point. And I'll check with that. All right, so now that looks right. So now we have 4 points. I just got rid of that last point that was connecting back. All right, so these are going to be the 4 corner points of our panel. And then the other thing we want to do in this case is we'll give a value for one of the parameters that we created for that panel. So we can do multiple parameters with this tool, but I'm just going to keep it simple and do one, which is the opening width. And I'm just going to do, I'll just create like a random set of numbers. Just to keep it kind of like quick, but you can kind of get the idea that you can create sort of a more logical workflow for this and start to assign these sort of values based on some sort of deeper analysis later on, and we'll go through some more examples, more advanced examples later in the class. So we'll see here random. If I hover over here, it's asking me for a range, a number, and then a seed. So I'm going to give it a range. So this is basically my opening width. And I know that these floors are roughly, I think, 12 or so feet. So I'm going to do something around like 2 to 8 maybe for my opening widths. So I'm going to construct a domain. And I'm going to do, oops. Go 2 to 8. So that'll be our range. And then our numbers, we want to essentially match the number of panels, or the number of faces in this mesh, essentially. So I can do that by doing the list length, so that if I end up changing my UV breakdown, this will automatically update. So this is telling me there's 187 panels, so that'll be the number of random numbers I'm creating. And I'll create another panel just to check here what's going on. Now I see that I got all my random values between 2 and 8. Now one thing I want to make sure of is that these lists are both kind of look the same. So right now this is a flat list, whereas this is a nested list. So I'm actually going to graft this. And what that does is it basically just puts each of these values in its own list, essentially. And if we wanted to clean this all up, we can also put on a simplify. This probably isn't necessary, but it's good to do just to kind of clean everything up as we're going. And I'll feed this in as the values, and I'll feed our points in here as the points. So what this is, these are just kind of the location of where I'm saving the file name, the family name, and we didn't create multiple types, so the family name and the family type are going to be the same in this case, and that's just based on the name of the file that we were just working on, so adaptive_panel. Okay, so now go back into here. And so we should be good to go. So I'm going to hit true. And essentially this is going to create a CSV file in that folder. So we have our CSV file. It's called panel points here. And if all went well, we should be able to bring this into Revit now. So I'll jump back into Revit. I'll actually go back to a 3D view so I can visualize the panels coming in. So I'll go to my add-ins tab, model builder, create elements from file. I'll go to my example here. So I have that panel point CSV, and everything else should be good. I'm just going to hit process, and this will take a couple minutes to process all the panels. You'll notice that this is, we had, I think, 187 panels, but this is essentially kind of like placing, so you'll see that this is a higher number. So essentially what it's doing is it's placing the adaptive component and then modifying it based on the value that we put in. So that's why that number is higher than you might expect. So we can actually see in real time these panels that are coming in. We'll notice that they're actually pointed the wrong way. So what we'll do is we'll flip them in Revit. But basically it just means that if we wanted to correct that for a future workflow, we would basically just change the order of the points that we're placing to reverse it. All right, so I'm going to go down to my generic models, adaptive panel, select all instances, and I'm going to hit flip here. So this will take a little time just because it's flipping 187 panels. But there you have it. You have panels with a bunch of random kind of openings. It's a little tricky to see. Maybe we'll do a different shade. It's a little easier. So we have our openings here, and we can, if we wanted to come back in and adjust If we wanted to make that one smaller, we can make it 2 feet, adjust it after the fact. So yeah, that was just kind of the overview of that workflow. And we'll, as we go, we'll get into some more. This is something that could have easily been done directly in Revit with Dynamo and things like that. But there's going to be things as we go forward that are probably better to do outside of Revit, which is why this video kind of does this workflow. So that's it for now. Thank you.